For as long as humans have gazed into the infinite vastness of the night sky, we have wondered, will the universe last forever or ultimately perish? This profound question has long stirred the imagination and curiosity of scientists, philosophers, and futurists. An impending cosmic doom may now be closer than we think. Emerging evidence suggests our universe's continued expansion may eventually halt and reverse into a collapsing death spiral. This shocking discovery challenges our prevailing theories about the cosmos and our place within it. As a society, we must grapple with unsettling existential questions and the ominous fate that may await us in a universe with a definitive ending. In this cosmic detective story, we will piece together clues from the frontiers of astrophysics and cosmology, pointing to a potential universal collapse. Exploring exhilarating new telescope studies, quantum gravity theories, and mysterious dark forces, we'll uncover our universe's ominous prognosis. Confronting the implications of living in a contracting cosmos, we'll realize newfound significance in our present moment. For most of recorded history, scholars theorized our static and unchanging universe had always existed and always would. In the early 20th century, astronomer Edwin Hubble observed galaxies accelerating away from each other. Play the cosmic film in reverse, and everything converges back to an initial hot, dense point, the Big Bang. This observation of an expanding universe led to the current reigning model of cosmology. Just as a firework detonates and expands outwards, the Big Bang 13.8 billion years ago hurled all the matter and energy of existence into motion. The galaxies continue racing apart to this day. Space itself stretches like a balloon as cosmic expansion progresses. Galaxies far across the universe recede from us faster than the speed of light. But what will be the ultimate fate of a relentlessly inflating universe? Currently, the universe's expansion shows no signs of slowing down. In fact, it appears to be accelerating, with galaxies whisking farther apart over time. Imagining this process continuing indefinitely leads to some bleak and surreal eventualities. In the Big Rip scenario, the increasing rate of expansion literally tears even the bonds between atoms and molecules apart. This cosmic death by disintegration unfolds around 100 billion years from now. Farther in the future, the heat death imagines the universe as an icy void. Stars exhaust their fuel, and the last vestiges of warmth radiate into the eternally expanding abyss. While depressing, many astronomers consider these doomsday projections unlikely. Newer evidence indicates the universe's current accelerating expansion may just be a temporary phase. The authoritative voice on this shifting perspective is Dr. Adam Rees. Rees won the 2011 Nobel Prize in Physics for the discovery of the accelerating universe. His research team conducts ongoing analysis of thousands of supernovas to precisely measure cosmic expansion over time. We assumed expansion would slow down over billions of years, Rees explained, but shockingly we found the opposite. This breakthrough revealed an unknown anti-gravity force propelling galaxies apart at increasing speeds. Rees named it dark energy, an implicit nod that this mysterious entity remains unexplained. Intriguingly, Rees's latest supernova data suggests the universe's expansion rate isn't actually increasing exponentially as expected. The rate of acceleration may be more limited than initially thought. His revised projections indicate a permanent, accelerating universe may not be the definite fate after all. The data suggests a turnover point ahead when expansion starts decelerating, Rees described. It's like going up a hill. Cosmic expansion keeps getting faster until a peak, then gravity takes over and it slows back down like rolling back down the hill. This enticing hint of a turnover point where universal acceleration halts and reverses is echoed by parallel breakthroughs in quantum gravity. These cutting-edge theories unite Einstein's general relativity with quantum mechanics to describe reality on the smallest scales. While speculative, certain quantum gravity models predict a cosmic turnaround as well. Quantum effects could introduce repulsive forces that counteract gravity and cause accelerated expansion, explained Dr. Margaret Rollins, theoretical physicist at Stanford University. But plausibly, this exponential growth hits a ceiling and plateaus. Then gravity regains dominance, pulling everything back in. What would the passage of billions of years beyond the turnover point actually look like? Far future cosmology paints a surreal portrait of the eons preceding cosmic collapse. 100 billion years from now, the accelerating freeze-out of star formation continues. The skies grow darker as existing stars exhaust their fuel supplies and fade. The last remaining galaxies begin to run out of gas to form new stars. 1 trillion years. The universe's declining temperature means matter itself gets cold and dead. Liquid and gases no longer exist. All planets and moons ultimately crystallize frozen solid. 100 trillion years, only burned out white dwarfs, brown dwarfs, and black holes remain. These cold remnants emit feeble heat as they shed the last of their residual thermal energy. The universe grows colder, darker, and more dilute. Quantum decay sets in on near-cosmic timescales. Even protons and neutrons making up atomic nuclei no longer endure. They gradually decay and fizzle out of existence. 100 octillion years. Gravitational collapse pulls streams of dead stars and black holes into an increasingly dense and compact cosmos. The sky brims with the light of billions of black holes consuming each other. As the projections near the hypothesized turnover point, predictions grow more conjectural. The destiny of the universe likely hinges on the complex interplay between quantum physics and gravitational forces we are just beginning to understand. As atoms break down, bizarre quantum effects start to dominate, Rollins suggests. This could unleash negative pressure from vacuum decay that counters gravity. Matter itself may disintegrate into its primordial constituents, turning the density of the universe back into pure energy. Some in the field, like Dr. Yuko Mizushima, even posit the emergence of anti-gravity dynamics. Expansion might stop and contraction start on vast scales, then new physics kicks in that can bounce the universe and reinitiate expansion, Mizushima explains. We live in the universe's first incarnation. It's still youthful. Despite valiant new theories, our ignorance of the quantum realm at these extremes makes the universe's climax impossible to accurately model. All projections end in a singularity, an intellectual brick wall. It's like our equations cry out. This is where I break down, Rollins laughs. We need a true quantum theory of gravity to pierce the end of the universe. Somewhere between 100 octillion and 1 decillion years from now, gravity gains the upper hand and universal contraction begins. The slow process of collapse lasts eons. As the universe shrinks, densities gradually ramp up. Stars ignite anew from fresh gas clouds in the increasingly compacted cosmos. The sky starts to re-illuminate after ages of darkness. Black holes merge and swallow each other at accelerating rates. Their billion-year rotating energy fields overlap and interconnect across the tightening void. Friction and collisions between black holes release intense bursts of gravitational waves. As the collapse accelerates, the sky morphs into a blinding white glow. The observable universe contracts down to a single supermassive black hole, swallowing all remaining light and matter. At the end of time, the supermassive black hole reaches a point of instability and finally implodes. All remaining space-time and energy collapse down to infinite density, a final singularity. This cosmic dead end marks the end of physics as we know it. We can't see past the horizon of a singularity, says Rees. Some new dimension may await on the other side. Or it may imply the universe gets reset or echoed over again. What does pondering universal collapse mean for humanity here and now? While the forecasted turnover point lies billions of years in the future, the revelations impact our present thinking. An end provides meaning. It makes the finite time we have all the more precious and profound, reflects Dr. Michel Louis, philosopher at the Equals Institute. The turnover point means we likely won't encounter the Big Rip, so that's comforting, she jokes warmly. But it reintroduces existential angst about our ultimate extinction. It's like we can't escape the end, only delay it. Physics rarely intersects with philosophy so pointedly. A universe with an expiration date raises poignant questions. Do our lives and endeavors ultimately signify if everything collapses? Does the inevitability of permanent darkness mean valuing laughter, light, and beauty today? A collapsing cosmos need not drain life of purpose and value, Louis says optimistically. It can reframe each moment as deeply meaningful. The finite nature of existence inspires compassion. We're all traveling cosmically in the same boat. The forecast of a contracting universe also elevates the importance of expanding knowledge and wisdom. If all sentient life faces oblivion, our efforts undertaken for the greater good possess a gravity and urgency. Louis smiles warmly. We have this bright, brief chance to know and shape the universe. That's no small gift. As with many dazzling discoveries, grappling with a universe bound toward fatal collapse leaves us with dizzying possibilities. This new vision of our temporary cosmic home invites awe at existence's impermanence. It unites us in making the most of our fleeting opportunity under the stars.